Alright, so in this video I'm going to be showing you the solubility rules, and first I'm going to start with showing you those that are soluble, and then I'll be moving on to those that are insoluble. So to begin with, what soluble means is that it dissolves and it would be aqueous. So you'd put that aqueous notation, the AQ inside parentheses notation, to denote that it's soluble, and then an insoluble does not dissolve, and for the most part it's solid. So if you have a group 1A element like lithium, sodium, you just look at the periodic table, the first column. Okay, so if you have one of these group 1 metals, ammonium, nitrate, acetate, hydrogen carbonate, chlorate, and perchlorate, automatically once you see any of these, that would make it immediately soluble. They have no exceptions. Then you have these two that are soluble for the most part, but if paired with any of these, they would become insoluble. So let me show you. If you have chlorine, bromine, let me zoom out a little bit. So you have chlorine, bromine, or iodine paired with, if they are paired with mercury, lead, or silver, then that would make it insoluble. So for the most part, these three elements are usually soluble, but if paired with any of these, it makes them automatically insoluble. Then if you have sulfate for the most part is soluble, but if it's paired with one of these three, and in addition to those three, calcium, strontium, or barium, that makes the sulfate automatically insoluble, and you won't be able to put the AQ notation next to it. Okay, moving on. So let me give you some examples. If you have NaCl, once you see this sodium, it's part of the group 1 elements, automatically makes it soluble. If you have if you have lead 2 sulfate. Sulfate is usually soluble, but because it's paired with one of the exceptions that it has, it makes it insoluble and therefore would be a solid. Moving on to the insolubles, if you have carbonate, which is CO3 2 minus, or if you have chromate, which is chromium without a 2, O4 2 minus, or if you have phosphate, which is PO4 3 minus, or if you have the sulfur element, which is a 2 minus, or hydroxide, which is OH. If you have any of these, they're usually insoluble. But if they are paired with a group 1 or ammonium, then automatically they would be soluble. And then the hydroxide right here is a little special case. So obviously if the hydroxide is paired with any of the group 1 elements or ammonium, it would be soluble. But in addition to those, if it's paired with calcium, strontium, or barium, then that would make the entire compound a soluble compound. So if you have calcium OH, you're going to have to put a 2 here because calcium has a 2 plus charge, then that entire thing would become aqueous. So because of this exception, it made the usually insoluble hydroxide soluble. And that wraps it up for solubility rules.